And let's see. Hello.
Hey.
Hi, there you are. Can you hear us okay?
Yeah. Can you
Uh,
hear me okay?
I can. Oh, yeah, really good.
Well, I
I
like your background.
Thanks. I was about to say the same thing. I like your background too.
Yeah, good selection of plants.
What's that?
Good selection of plants there.
I know, right? They're all like really struggling, waiting for the spring. It's like 10 degrees outside, Fahrenheit. So what is that in Celsius? Like -10, something like that. I know.
Cold. They're suffering. So you're trying to keep them inside, keep them warm a little bit. Yeah.
It's horrible, yeah.
Yeah. So this is my co-host, Ella Gilbert. And
nice to meet you.
Yeah.
Nice to meet you too.
Yeah. And yeah, thanks. Let me just start off by saying thanks so much for being here. I really appreciate it.
Thank you. This is my one podcast that I've ever done.
You're
Oh
one.
yeah, a baptism of fire, I'm sure.
What's that?
A baptism of fire, I'm sure.
Is
We'll
it?
see.
Not at all. No, that'd be great fun.
Is that what we do? I don't think that's what we did.
Oh, sorry. Did I not get the memo, Dan?
Tone it down.
I'll just tear up my notes.
Yeah.
Okay, see you later.
Yeah. Well, it's been good talking to you. I gotta get out of here. Oh my gosh. Oh, I wanted to ask, is it pronounced Mika or Micah? Which? Mika. Okay, cool. I was realizing that even though I've been following you on Twitter for a very long time, I was like, oh wait, I've never heard her name said out loud before.
Didn't we meet like a long time ago at like some young scientist in southern France or something? Am I getting that right?
Close. We did actually meet in EGU in Vienna.
Oh, EGU.
Yeah.
That's right.
It might have been 2014. It might have been that long ago.
13,
yeah.
Maybe even earlier. Somewhere around there. Yeah.
Somewhere around there, yeah. So we sat around, we had pizza with a few people. Oh gosh, his name escapes me. I went to grad school with him. Shoot. No, Levi Silvers was there.
That's right. That's
Yeah.
right. I remember very distinctly. Like, and then we walked around or something, got drunk.
Yeah. I'm pretty sure we did. I really remember it too, because I don't remember a lot of specifics, but I remember in my memory, we had a lot of fun. We were like laughing a lot. So like, I remember it as like a really good time.
It sounds like quite a classic EGU experience, pizza and beer and drunkenness.
I think that's right.
Yeah. With maybe some science thrown in there here and there if we feel
a little bit.
Yeah.
A scattering.
That's right.
Like a topping on a pizza.
Yeah, exactly.
Oh man. So there's not really like a rigid structure or anything. It's meant to be pretty conversational. I've got a list of notes and things down here, but it's not meant to be like an agenda that I march us through. It's just meant to be fuel for the conversation, things to kind of keep us rolling along there. And yeah, and by the way, I'll send you everything before I release it so you can make sure you're happy with everything. And if there's stuff you want me to cut out, that's totally fine. You'll have an opportunity to do that. So I record right from the beginning because I like to get some of that stuff, but I just think it's kind of nice. I like those first moments and things. So there's lots of different stuff we could talk about, but and this question is far too big, but I was wondering if you could just tell me everything, not literally everything, but if you could tell me a lot about that connection between wildfires and clouds and the climate system. It would be great to hear about that, and especially if there's any kind of recent projects you've been working on in that kind of area, because I really know very little. Ella knows a good bit. She knows a lot about clouds, and but I don't know hardly anything about that connection there.
That's cool because clouds are, I think, continue to be one of the most vexing problems in climate science, and probably Ella would agree.
Yes.
And I think one of the main sort of issues with that is that cloud formation and the physics that dominate how clouds are formed, how clouds rain, where they move, etc. Why clouds rain, sorry, is it's so regionally specific. It's really like meteorologically specific, and so you know I set out in 2006 at the beginning of my grad school program, trying to investigate the ways that aerosols emitted by fires, particulates emitted by fires, interact with clouds, and also just the radiation budget, kind of more broadly. Um, and immediately I was confronted with this sort of problem that you can't really, there's no real like answer, there's no real like universal answer to this. It depends on where you are, what time of year, how big the fire is, what color or brightness or darkness of the aerosols, what kind of cloud, what time of day. So there's like a, it's just like an endless problem, which I mean, Ella is nodding along, so I think it's all, pretty widely understood. I think it's, but I will say that most of my research prior to coming to where I am now at SAIC, which maybe we'll talk about later,
Yeah.
is was looking at tropical forest fires, tropical wildfires. Specifically, I focused on kind of like two main regions: Equatorial Asia and kind of sub-equatorial Africa, I guess you could say. So the Sahel region and southern Africa, like kind of on the outskirts of the Congo rainforest. And the reason that I selected those regions to look at is because A, they're very interesting. B, they're very understudied. I think there's just like a dearth of literature and a dearth of or at least at the time, when I started this, there was like a dearth of, just research into these regions. There's a ton of research on wildfire in North America, for example, but most of the wildfires on Earth actually happen in the tropics, and specifically in Africa, actually, which is like one of the most understudied continents if we were to sort of look at the whole continent climatologically, which was a big reason why I participated in a field campaign in 2016. Now it feels like so long ago,
Yeah.
in southern Africa called Oracles. Maybe you've heard of it. It was a NASA. It was, I think, the agency that led the project was NASA, but it was in collaboration with a bunch of other scientists from other places like the University of Washington, Miami, in Florida, etc. So the kind of big message, I guess, that I derived from my research, the answer, so to speak, is that so I'll cut to the punchline first. Is
Sure.
that wildfires, specifically in these regions that I'm talking about in Africa and in Equatorial Asia, they emit smoke particulates that are kind of a mixture of organic and black carbon. They're reasonably bright, but they're also somewhat absorptive. They're not as absorptive as like, dark black soot, for example, but they're fairly absorptive. And so they interact with clouds. The main way that they interact with clouds that I found was through what's known as the semi-direct radiative effect, aerosol radiative effect, which basically is, I mean, I've got a whole lecture on this for my students, but I'll try and trim it down to like 30 seconds. They while suspended in the atmosphere, in the middle atmosphere, in the boundary layer, they absorb sunlight from the sun. LOL, sunlight from the sun. They absorb sunlight,
Yeah.
and that causes that layer of the atmosphere to heat up. It also causes the layer below it to cool down. And so this reduces what we call the lapse rate. It reduces the instability of the atmosphere.
Yeah.
So air rises in the atmosphere because it's colder aloft, and so it rises up through a number of different mechanical and non-mechanical processes. But when you put aerosols in this layer, and they're absorbing sunlight, they're absorbing radiation, they're warming the layer, they're decreasing the instability, and so the end result is that they're decreasing the ability for clouds to form. So clouds form via this unstable regime in these regions that I was studying. And so when you introduce aerosols, we found both in model results using global climate models and radiative transfer models, and also through satellite observations, we found that, and I can elaborate on that too, but we found that this decreased overall ability of clouds to form, and I hypothesize and continue to hypothesize that this would have a positive feedback effect where you have fires which are during the dry season, so there are already less clouds started by humans, most of them in these regions. They spread because it's the dry season, and so there's a relationship between how cloudy it is, how rainy it is, and fires, right, spreading. But once those smoke aerosols get up into the atmosphere, um, induce this semi-direct radiative effect, reduce cloud cover even more. This would then in turn potentially fuel the fire even more because you have a less cloudy sky, you have a less rainy atmosphere, and so then you have more fire. The one component that's missing is the human response, right? So since these fires are started by humans, we don't really know. There's not really a robust way necessarily to test whether humans are actually responding to the less cloud cover, but my hypothesis, I guess, is that they are, and that these fires are kind of operating within a positive feedback framework. Hopefully, that is what you were looking for.
Yeah, no, that sounds really interesting. I was just found myself wondering about, is that a relatively local effect? What's the kind of spatial scale of that connection between the fire and the cloud cover? And I also thought it was really interesting what you were talking about aerosols changing the lapse rate, the rate of change of temperature with height, that kind of stratification, the kind of way the atmosphere is all layered up. And it's one of the things I can relate that to is ozone. Ozone up in the stratosphere does something similar where it changes how some of the radiation from the sun is absorbed. So it changes where the heating happens. And to work that out numerically, to deal with that numerically, you need this like a nice numerical model with lots of layers where the layers can all exchange energy with each other to see what the net effect is. But yeah, and that's obviously an atmosphere-wide process. But is the fire process that you're talking about more of a local one, or can it affect a larger spatial scale than just where the fire is?
Yeah, so it depends. It depends.
Mhm.
Every answer that you're gonna
Yeah.
get from me is like it depends. But it depends. It depends how big the fire is. Depends where the aerosols are being emitted. Um, and it also depends what kind of fire it is and what
Mhm.
time of day. But in general, I would say it's a fairly localized effect. Yeah.
Okay.
Um, in Africa, for example, the fires are generally agricultural burning. They usually burn the fields both after the growing season and to kind of recycle the nutrients into the soil. It's kind of a natural fertilizer. They've been doing this cultural practice for millennia, actually,
Mm.
in Africa. Um, and there's some great papers on it by like Sally Archibald, for example, who writes about like fire in Africa, history of fire in Africa, and kind of all about that. I highly recommend. But those fires are each individually very small, but there's like, thousands of them, millions of them. And so they create kind of a more homogeneous smoke plume that kind of covers the continent and actually drifts out over the Atlantic Ocean. And if we're thinking about for example, southern Africa, it would drift out over the South Atlantic Ocean, and if we're thinking about northern Africa, it would drift out over the North Atlantic Ocean, which has potential implications for cross Atlantic travel of that
Mm.
smoke. But in general, the effect is fairly localized.
Okay.
Yeah.
Yeah.
So
But it
if
also depends. It depends on kind of where they are in the atmosphere too. And so
Mm.
actually, my current research, like where I took this, was looking at like vertical distribution of smoke emissions, where they go, because that impacts like, are they going above the clouds, below the clouds, into the clouds? That's really important.
Cool.
I was just going to ask, because you say that I guess that smoke drifts out over the Atlantic or whichever ocean we're talking about. Does that then have an impact on something like the marine clouds? Because, of course, aerosols are going to act as cloud condensation nuclei and act as little seeds so that more clouds can form. So is there like almost a cascade of processes that can trigger more clouds later on of different types?
That's a really good question, actually, and that was like the primary focus of the Oracles campaign. Actually, was looking at
Interesting.
how these smoke aerosols impact marine clouds. It's not something that I, in my research, have focused super heavily on. I was looking more at like convective clouds over land. But absolutely, like there's been a number of papers. I actually just reviewed a paper by the Oracles team looking at above cloud aerosol optical depth and how we determine that and what that means for the clouds below it. But in general, in Africa, um, if we're talking about Africa, the smoke is going above the marine clouds. And
Yeah,
so
they're quite
that's
low,
very
aren't they?
different than the smoke that's going into the marine clouds from, for example, the smokestack on a ship, right? So we often talk about uh, ship ship tracks, which is like usually like a cargo ship or a ship that's moving goods. Um, Below a layer of marine clouds, and that's going to have a very different effect than fires above the clouds. Generally speaking, um, the ship tracks, um, because they're coming from below the clouds, they enhance the brightness of the clouds through like a sort of microphysical effects.
Mm.
And the smoke above the clouds, the aerosols above the clouds from smoke in Africa, has a very different effect because it's if viewing from space, it's going to be darker than the clouds below it, and so it's going to have a totally different effect, similar to the one that I was just describing, the semi-direct effect and the absorption of radiation and all that kind of thing.
It's always so interesting to see how the kind of the dynamics interacts with things like chemistry and the microphysics of clouds. I always think that's fascinating, how things like the lapse rate or the stability of the atmosphere, where you've got this changing profile with height, and things like the size of ice crystals or the actual composition of these things that are getting emitted, how it all fits together. It's clouds, they're fascinating.
Yeah, and there's actually been kind of a I don't know if it's like controversy, but there's a lot of sort of competing theories about specifically about these like convective clouds. So
Mm.
most of like the subtropics will receive their rain in kind of these what we might think of as like monsoonal convective clouds, right? They're not like large scale advective systems that would come across like Europe or central mid latitude regions in North America. These are like convective clouds. I like to call them like Simpsons clouds because they're kind of like cumulus and cumulonimbus, and so there's kind of there's the semi-direct uh, theory that I'm talking about, but there's also these indirect microphysical effects that you brought up, which is that the aerosols in the clouds actually change the microphysics of the cloud particles themselves, the cloud droplets themselves. They make them smaller potentially because if you introduce more aerosols, then you have more cloud condensation nuclei, and so the individual droplets become smaller. And so there's a theory that as these droplets are in this dynamic convective cloud, they get carried up higher instead of raining out right away. And as they do that, they turn to ice, and this ultimately makes the cloud rain more, which would be kind of the opposite effect of the semi-direct effect, which would make the cloud kind of not form at all or form in a much more limited way. And so there's no real answer to
Yeah,
this,
yeah.
and that's why I was saying it's very regionally specific, and it can be very like localized, like meteorologically.
It's just classic clouds, like being really complicated and having loads of competing effects. It's the same
Jerks.
wherever you are. I know, it's such a
Totally, and it's kind of a chicken and egg thing too when you're looking at like satellite data, because you're like, I've got these aerosol data, I've got these cloud data, and I'm drawing some conclusions, but it's like which came first, you know? And that's always kind of been the overriding difficulty with all of this research, which is why aerosol cloud interactions is like something that's still very much ongoing, and people are still very much thinking about it.
Yeah. So you're giving us a picture as to why, when you look at all of the, the uncertainties on the climate forcing picture from the IPCC reports, why the cloud feedback one is so big. It's because it's
Yeah, the error
so,
bar is like on the screen. Yeah.
yeah, because it's so multi-scale and so specific.
Mm-hmm.
And that leads me to kind of my next question about often in climate science, let's say we have an understanding of a process, like a kind of local process or a relatively smaller scale process. And then what some folks try to do is to get those things into climate models in some way, some representation of that process in the climate models, so that we can ask questions and quantifiably address questions like, oh, what's going to happen to this under different emission scenarios into the future? So I don't have a good sense. Um, the effects you're talking about, are they in some of the climate models, or how does your field, deal with making climate projections over something that is so multi-scale and complicated?
Yeah, so they are like during my time in grad school was when there was a lot of interest in including these in climate models, and so
Yeah.
I think most of the major climate models now include all of these aerosol effects. Now, how good they are is still like super debatable, and
Yeah.
also like the word good is kind of what does that mean?
Right.
Um,
Right.
but generally speaking, when we talk about aerosol effects on climate, we're talking about like three distinct ways that aerosols interact with climate, and the third way kind of has an A and a B part to it. So the first way is the direct radiative effect, and that's been included in climate models for a while. That's just direct absorption of insolation of sunlight, solar radiation by aerosols in like kind of a clear sky. So you can think of the direct radiative effect. Oh, it can also be absorption or reflection, depending on the type of aerosol. But it's kind of the direct interaction with radiation. And so, generally speaking, the direct radiative effect cools the surface because
Mm.
it's kind of like putting an additional cloud in the way. And those are that effect is the most well understood of the aerosol effects and has been included in climate models for a while, and I would say is fairly robust. The semi-direct radiative effect is related. It deals with the interception of radiation by aerosols, but the impact on the climate, the surface temperature, shall we say, or like the precipitation, is actually from the cloud itself, right? So it's not the aerosols. It's kind of complicated, right? But it's like the aerosols absorb the sunlight. They do this whole lapse rate modification thing. They heat the mid layer of the troposphere, and then this reduces the cloud cover. And so with reduced cloud cover, you get a warmer surface theoretically, right? And so this would have a warming effect on the climate, whereas the direct radiative effect typically has a cooling effect on the surface, and kind of a mixed effect on the atmosphere. Then you've got the radiative effect, and that semi-direct effect is now kind of included in climate models as well. And I think it's pretty reasonably well represented. Then
Yeah.
you've got the indirect effects, which Ella probably knows a lot about too, because if they study clouds, um, this is like the big question mark. So indirectly, aerosols can change the droplet size of clouds and either make them brighter or usually make them brighter. And so this would have potentially, excuse me, a cooling effect on the surface, really dependent on like what type of cloud. So if it's a
Mm.
low cloud, fairly well understood. If it's a cumulus cloud or a high cloud, not as well understood.
Mm.
Um, and so this indirect effect, there are some representations of it in climate models, but I think it's the least understood and the
Yeah.
least well represented.
Yeah. Still lots
Yeah,
of.
for sure. I mean, that's in fact what I'm working on
Hey.
to try and
Oh,
get it
Really?
better in high clouds at the moment,
thanks.
Interesting. Yeah.
Thanks.
using a completely different scale of model.
Yeah. Well,
Yeah,
I'm
when I
glad.
was in grad school and my postdoc, I was working with the American CESM, the model that's run out of NCAR,
Yeah.
and I think they do now have all three kind of aerosol radiative effects included in the model. I can't speak necessarily to all of the climate models
Yeah.
that
Yeah.
exist in the world. There's like 30 of them or
Yeah.
something or more.
That's
But
that's right. Yeah. Yeah. If you knew about all of them, I'd be impressed and a little concerned also. Like what?
Someone's CMIPS encyclopedia.
Yeah.
my pandemic adventure is like figuring out whether the radiative effects are in all the no, oh my god.
Yeah, please tell me. You've had another
Yeah.
project.
Well, I know, Ella, you've got a deadline, so you need to get out at some point. So I was wondering, should we talk about your work at the School of the Art Institute of Chicago? Would that be good?
Sure.
Yeah.
Yeah, whatever you guys want to talk about.
That would be great
I've had
because
my coffee and I'm good. I'm ready. So
nice, excellent. Yeah. So you moved to the School of the Art Institute of Chicago as a professor, and one of the reasons that you decided, um, if I can kind of paraphrase, was that you feel like that artists can teach us a lot about how to communicate about climate change with the public. That you had some concerns that we're generating all this climate knowledge, we're doing all this work, and the concern is that it's kind of staying behind this wall. Not intentionally, we're not trying to keep it from anyone. We're just not especially that great at really getting it out there into the world. So I'd be interested to hear about your transition to that school and how you found it and in what ways you're plugging into this collaboration with artists to try to communicate science better.
yeah, totally. I mean, it's been a really interesting past 4 years. Not least because of this move to the Art Institute, but uh, it all started in 2016. I was feeling pretty restless. I was working at the Jet Propulsion Lab,
Mm.
JPL, in Pasadena, doing this cloud and aerosol research, and very much enjoying it, but very much feeling like um, I don't know. I was having like climate anxiety, maybe like climate change anxiety, and I was like, I need to do something that's not like sitting at this desk in an interior office at JPL, like
Yeah.
plugging away. And so I started looking for jobs, and I saw this position open up at the School of the Art Institute, and I was like, well, that's weird. And I had never been to Chicago, and I was like,
Mm.
but I don't know if I can do the winter, so we'll see. And then I got
Mm.
an interview, and I got an interview, and I went, and I was like, um, I was really into it. Actually, they sold me. They totally sold
Mm.
me. They said like it seemed like a really cool opportunity. They had 4 full-time scientists already working at the school, not climate scientists, but just scientists. I guess briefly, like it's an accredited university, and so the students have to take these um, what what I call like regular classes, academic classes, let's
Yeah.
say, that are not like fine art studio classes.
Right. Right.
And so they, instead of outsourcing them to the community colleges or to other colleges, they decided to sort of beef up their liberal arts department. So we have many full-time historians and philosophers and English and writing professors and scientists, and it's actually very cool. So I was totally sold. And then, but I was a little bit, sad about leaving JPL. I thought I love, I love and still continue to love LA, where I was living. And I was participating in this field campaign in 2016, which is when I was offered the job. So I was like, let me go on this field campaign and then maybe I'll start at SAIC after. Um, so I went on this field campaign in the summer. I came back. Donald Trump was elected president, and I was like, I have to go to. I must go to SAIC. I have to do this.
Mm.
It's urgent. It's important. This is the
Yeah.
perfect opportunity to make this life change. I also, as a trans woman, I started my transition around this time too. There was just
Mm.
a lot of urgency in 2016 for me. I was like,
Yeah.
climate anxiety, my gender, Donald Trump. Like, I was like, fuck, the world is like,
A lot of big things there.
So I came to SAIC and yeah, and then I kind of shifted gears and started thinking about the ways that artists and designers can improve not just our communication of climate change, but also the way in which we actually conduct science and construct scientific knowledge.
Mm.
So actually, this podcast is like perfect timing because I'm about to submit a manuscript finally summarizing kind of all of this work that I've been doing for the last 2.5 years,
Oh, nice.
thinking about these ways, and I think it's going to be really cool, and I love talking about it, honestly. So there's like so much to go into, but I do think artists have and it hugely can play a hugely important role both in communication and in production of knowledge.
Can you give
Yeah, I
us
mean, I think
some
it's
highlights
such a
from that?
fascinating
Oh,
thing.
sorry.
Sorry to interject. It's so often seems to be one way though, like as in, hey, we need to take this approach from art or design or whatever sort of creative industry it is and adapt it for science. Whereas I think it sounds to me like from your work, you're doing much more of a collaborative
Absolutely.
dialogue. So
Absolutely.
you're both benefiting both parties, and that sounds absolutely fascinating.
Yeah, I like to call it radical collaborations between artists and scientists.
Nice.
I think, yeah, you nailed it totally. Is that after speaking with a lot of artists, my students and colleagues, um, because the one thing about being a scientist and then being thrown into the art institute is that while I am still teaching science, like my courses are science courses, I teach numbers and science to art students. It's very cool. Um, but I am like in the art world, very much immersed in the art world, which means I had to learn a whole new language um, to communicate with artists because they just as scientists, like, we have our own language, we have our own way of communicating with each other. Artists also have their own way of
Baryclinic
communicating.
instability.
So yeah, exactly. And, and
A whole
so
different language of jargon to learn. Wow.
jargon, language, everything. And so once I was able to sort of communicate with them, um, the thing that I heard the most was that artists are really interested in being engaged with science, actually, but that they often feel slighted by science, capital S science, TM, the industry, if you will, to being relegated to, like you said, Ella, these like the whole project is done, and then they're like, hey, can you make this graph prettier for me or
Yeah.
something, or can you
Yeah.
make this image like into an infographic that someone can understand? And while artists are often going to take those jobs and often going to do that stuff, because I do think that they're really like morally committed to solutions to the climate crisis, what I heard the most was that they wish they could have been involved in the process from the beginning. um,
Oh, wow.
that this could have been a collaborative project, and that they could have influenced both the scientific process and also the dissemination of the results from a much earlier stage than like, oh, here's my results, can you like make them look good,
Yeah.
you know?
Yeah.
And I think that this actually comes down to scientists not really understanding what artists do,
Mm,
um,
yeah.
personally. And I can say this because I've done a lot of growing and learning on this subject. But before I came to the Art Institute, mm, I don't know. I get like, maybe this is gonna sound really bad, and maybe I'll get like a bunch of comments. But I just didn't think artists were really that smart, in tune with like the science, in tune with the, But they're incredibly astute. They're incredibly smart. They do research just like scientists do research. They produce works that are brilliant and engaging and like accessible, and some are inaccessible, too. But I think that scientists have this idea. I'm always reminded, like, you go to a museum, let's say, and you see some sort of abstracted piece of art, and a lot of times I hear scientists and other people say, like, I could have made that, and it's like, no, that's not really how this works. Something that I've learned from being at the Art Institute is that art is as much the thing that was made as it is the process that was used to make it, which is exactly science, right? Science is both your results and the methods that you got there with. And so there's actually so many similarities that I was like, this is a ripe opportunity for collaboration, that we can learn a lot from each other,
Yeah.
all in the service of solving the climate crisis.
I wonder if we can get a little more specific there. Is there an example you could give us, or is there, yeah, I don't know, is there something that we could dig into? Because I think I have some sense of what you're talking about, but feel like I want to grapple onto it a little bit more.
Yeah, sure. Of course I do. So this will some of the projects that I've been working on, like, over the years, really grapple with this question. And so before I get to those, I think a really broad kind of example that I use a lot is science fiction literature.
Mm,
So science fiction, and especially I'm particularly like having a moment with Octavia Butler's science fiction works, which deal with, and sort of more broadly, Afrofuturism as like a way of art making, as like an art production medium, um, and basically the idea here is that uh, the human imagination is amazing.
mm,
It's we are able to imagine so many things, and the what better way to capture like the human imagination and to kind of like provoke the human imagination than with art. And I'm using
yeah.
art really broadly here as like just a creative output, excuse me, like an art object, so to speak.
Mm-hmm. Mm-hmm.
And so, you know, like Parable of the Sower, for example, which is one of Octavia Butler's probably more famous, well-known works, finally reached the New York Times bestseller this year. And I think a lot of it probably has to do with the fact that we're in this sort of like apocalyptic situation. And and her novels, as well as many other Afrofuturist works of art, um, both are fictional like narratives, they're science fiction, but they also have this vision of the future, this like liberated vision of the future, which I think is like necessary if we are to ever have a liberated future. If we are to ever have a future where we've solved climate change, where we've solved all these problems, we
Mm.
have to imagine it first, right?
Yeah.
We have to get there first before we can build it. And
Yeah.
I think scientists sometimes are really bad. They think about the building it step first, but they never think about the imagination step.
Yeah, yeah. I'm reminded of a couple of things. One of them is, I mean, it's maybe a little bit cliche or well known, but that was one of the things Einstein used to talk about was how important imagination was to him and to his science. He's like, no, I have to start with imagination. That's the beginning. Just,
Yeah, it's the
picturing different,
destination, isn't it?
yeah, picturing different
Absolutely.
realities. And
And I think science has become so like production
mm,
based, or you know, I like to say that like this we're in kind of a post enlightenment scientific moment right now where scientists are often producing science for other scientists. Um, you know, and that's fine. I think scientific knowledge is like really important and that we should keep pushing on these things. But I also think we have like there's some urgency with the climate crisis,
yes.
and I think that um, we have to figure it out. And so one of the things that I really talk about a lot in all my public lectures and in this paper that I'm about to submit is that the scientific method, which I'm putting in air quotes because it's not really a thing, right? But it's
Mm,
typically kind of thought of as you have a hypothesis where you're kind of looking at data, you're looking at scenarios, and you're kind of coming up with a question, and then you test that hypothesis, and then you can have some conclusion, right? That's not all that different than, like, for example, the design process or the art making process, where you have a bunch of like ideations, and then you have some prototyping, and then you have a refined product. The difference is that both art and design begin with a really important human engagement step, a contextual inquiry, like talking to actual people. Like, what do you want? Like, what are
yeah.
your concerns? What are you imagining for this thing that we're designing or that we're making? And that step, I think, has been lost from the scientific method in a way. Like, there's just not a lot of engagement with stakeholders. There's not a lot of, you know, contextual inquiry with like actual human beings. And so I argue that the most important thing that scientists can learn from artists is that we should talk to people more, more,
Sounds like a
you know?
really good piece of advice. I'm really interested actually in like what that sort of, as you said, radical collaboration, what that process looks like. Do you sit down and talk together? Is it a very kind of integrated thing? Is it one-on-one? What does that look like?
Yeah. Okay. So a good example that I have is uh, two, three, 2.5 years ago. I started this project with the design team at JPL. So I was at SCIC, but I was working kind of part time with JPL, and this is like a full circle moment of our conversation here. But we have this database of wildfire smoke plumes that we've created using a software that I helped design while I was at JPL, which kind of uses our satellite to estimate how high in the atmosphere the smoke goes. And we've got this database of like thousands and thousands and thousands of smoke plumes that scientists and anyone could go and download and then answer questions with, do climate research with, blah, blah, blah. The thing is, nobody was using it.
Mm,
And so we were like, why? And I think that the main reason is because the data are so abstruse and difficult to access, and the interface to access them was like so confusing and so
mm.
complicated. So we said, okay, let's scrap the whole thing and like let's sit down with the design team and let's like do this over.
Yeah, yeah, because you
Let's
go to some of these websites, it's like just kind of plain HTML, lots of tiny hyperlinks all over the place,
Exactly.
acronyms, just a wall of acronyms everywhere, basically. Like,
Acronyms are really like a NASA specialty, you know? Like it's like
oh yeah,
acronym after acronym, a whole sentence of acronyms.
yeah, and compounded. They're like nested. There's acronyms within other acronyms, and yeah,
No,
yeah.
there
So
really are. Yes.
redesigning the
I'm
yeah. Let's
laughing.
scrap that. Let's redesign it. Right? Yeah.
And so we started yeah, we worked with these designers and we worked through like what I was just describing, where we did this like human engagement contextual inquiry, and then we had iterations with scientists, and the end result was, yes, like a really aesthetic, much improved interface for the data. But then I took it a step further, and this is what I've been working with my designer friend, Adrian Galvin, who I'll give a little shout out to because he's
Hmm.
brilliant and so helpful. Um, we were like, can we? Does this actually work? Like, did this actually improve the science that can be done? And so we sat down with several scientists, and obviously this wasn't like a thorough sociological study here, but social science. But we looked at how the interface itself influenced the way that the scientists interacted with the data initially. The big takeaway is that it removed this like intimidation. It removed the because when you log on to one of these websites and you're like, I really want to answer this question, but first I actually have to learn, how to download these data in my like Linux terminal, and I just feel like it introduces this whole layer of like knowledge that takes away time and effort and energy and motivation from the actual science questions that you want to ask. And so
Yeah.
I think sometimes when you have this like easier to access interface, you remove some of that, and then you get to just do the science, right? You get to ask the scientific questions. And so what this taught me was that um, design and art um, are not only valuable in like the ultimate communication of these results, but actually like the production of them, like the
Mm.
asking of questions, like are you even asking the questions that you should be asking and stuff like that, and so this is replicated it with my students as well, who for their final projects in all my classes I have them take a climate change impact, or something that's an environmental disaster, and then I have them do research on it, create an art object on it, and then we look at that art object together and we think about it, and that then in turn influences like what questions I'm going to ask, what questions the scientist who's viewing this might be like, I never thought of it that way before,
Mm.
and now I'm going to ask this other new question, and
Yeah.
that might actually be in better service to ultimately solving the climate crisis. I know that this sounds probably really abstract, so if
No,
you
but inspiring alternative perspectives and like a fresh set of eyes and a fresh approach to something is so useful,
Yeah.
because I mean, so much in science we follow the same rules all the time, same angle all the time,
Yeah.
and just having the opportunity to think about something from a completely different way, I bet is
Yeah.
amazing.
And when I just got this picture in my head of, you know, we often work with this set of tools which aren't necessarily very intuitive. I mean, I like command line stuff pretty reasonable. It's powerful, the command line's powerful, but it can be intimidating, and I'm always having to look up commands. So I just got this picture in my head of the kind of typical toolbox of scientists is it's a bit jumbled, right? It's a bit messy. There's wrenches of different sizes, and you got to kind of jam your hand in there to pull out, exactly what you want.
Mhm.
And versus you could imagine a totally different way of laying out all your tools in this beautiful interface, and kind of right where everything is. And under which one of those circumstances do you feel more creative and imaginative and inspired? When you got to dig through your toolbox and avoid the rusty like edges of it, or when you have this beautiful layout and you can it makes it easier
Yeah.
to kind of plug into it and get excited about it, I think.
Or it's like, if you can't see a quick maybe visualization of the data or abstraction of the data, you may download all these data, spend 2 days writing a Python script to like
Mm.
remove the text header, and then by the time you get it into like a netcdf file where you can graph it, you're like, oh shit, like these are not even the data I wanted. But if you could do that in an interface
Uh,
and say like, actually, I don't want to ask this question anymore. You've just saved like a week, or
Yeah.
yeah,
more.
Oh,
And
so useful.
that's right. That's
and
right.
it's stuff like that where like maybe you could eliminate some of the questions that, because I think sometimes scientists, we go into things and we're like, this is a great question, and then we start looking at it, we're like, actually this was dumb, like I shouldn't have asked this question, and I
Yeah.
shouldn't have done this. If there was a way that you could have imagined it differently at the beginning, then maybe you would have asked a
Yeah.
different question, and
Yeah.
that would have ultimately been in service of the outcome that we're desiring, which
Yeah.
is, in my case, you know, not devastating climate change.
Yeah. I mean, that's a good
Mm.
goal for all of us to work towards.
I'm imagining writing grant proposals, and often like that process would be much more efficient if you really could quickly get a sense of, is this feasible? Is this, should I actually write a proposal to spend the next 2 or 3 years,
Yeah.
really digging into this? Whereas
Mm-hmm.
sometimes it feels like even establishing that takes so much work, and we're probably wasting a lot of, human time just trying to even understand if things are feasible or not.
Totally. And not to mention, like, is the work that you've done accessible? I mean, like, not all scientific knowledge needs to be necessarily accessible to everyone. Oftentimes, I think we do want our science to have like a wide reach. And, I just wrote a proposal actually with some art and design folks at the University of Illinois in Chicago. And, there's this incredible data set of like, um, Chicago temperature and precipitation and humidity, all these data, like in each of these neighborhoods, like a very, very, very fine, high resolution data set. But we thought like, how amazing if like actually residents in Pilsen could like access these data and like understand these data. Um, it might influence like political action. It might influence like how people talk about these things. But the data are just so it's like so cumbersome to even
Yeah.
approach them, and so it's like, uh, what do people want? What do people need? Not that that always has to be the case, but like it can go a long way, I think.
I'm reminded of in Bremerhaven, Germany. This is a little bit more just on the science communication sort of side, but in Bremerhaven, there's a climate house. It's a climate museum. It's a whole. So you go in, and there's, for example, one of the things I remember is a slide. So the slide has both temperatures. It's like a slide you can climb on and kind of play on. It's got temperatures, a representation of temperature, and it's kind of representation of CO2. So it's a physical object you can interact with that kind of shows that relationship between the two things. So it makes it something more concrete.
Mm-hmm.
And I can't remember the specific example, but I feel like I've seen examples of pieces of art that are physical objects that respond to something in the real world. Maybe it's the size of a particular glacier, or something that shows the tides, some small sculpture that kind of is remotely connected to some other data set, some other real-time data set.
Yeah,
Yeah, something to make
yeah. I have
these.
like, no, sorry,
Yeah.
go ahead.
Oh,
Sorry.
yeah. Sorry, just going to say something to make the abstractness of climate change, the abstractness of planetary change, a little bit more concrete and tactile, and something you can interact with potentially.
Yeah, I've got a student actually. So, in this is also kind of will be written up in the is written up in the manuscript. But I have a student who took the recording that of Jimi Hendrix performing the Star Spangled Banner at the 1969 Woodstock Fair, and he modified the sound of it with a sinusoidal curve of carbon dioxide emissions
Oh,
or
wow.
carbon dioxide accumulation in the atmosphere. So it becomes
Wow.
increasingly dysphonic and louder and softer based on that as you go through kind of the song. And so it's really cool because there's so many layers. Like, first of all, the Star Spangled Banner, we all know like how implicated the United States is in the carbon dioxide concentrations in the atmosphere. Um, it was
Yep.
in 19. It was at Woodstock, which is kind of this emblematic of this sort of like leftist kind of rebellion against kind of conservative ideas, which many of which have led us to this crisis to begin with. It's also like he used the data set from 1969 through 2019, so it's like a 50-year data set, and it's like already kind of a dysphonic recording. There's a lot of politics involved, and it's just so cool. And then there's also like tons of science. Like he took this like concentration of carbon dioxide in the atmosphere, applied this fast Fourier transform to it, converted it into like a sinusoidal curve, and then laid that on top of the sonic sound of the song. And it's just like so brilliant. And I just feel like you just listen to it and you're like um, automatically thinking about all these things. You're automatically thinking about the carbon dioxide in the atmosphere. You're thinking about the politics of the 60s and like why we're here now when we knew about climate change so long ago. Like, there's just so many
Oh,
layers to it. And
That's
so that's like a
amazing.
really good
Yeah.
example. Yeah.
I was wondering,
love
that's
that.
made me think. I saw on your website that you did another collaboration with, was it techno artists?
Yeah.
I mean, as a massive fan of electronic and dance music, massive gabba head, that sounds really, really cool. And
Yeah.
that,
Oh my God, me too. I'm like a huge techno fan, and I'm so sad this pandemic. I haven't been able to go to any
Yeah.
live music. But anyway, yeah, it's cool. I had a student. Actually, I'm really like overwhelmingly interested in sonic representations of climate data.
Yeah.
I think there's been a lot done on the visual side, but I think there's like a lot of room for the sound side of things, and
Yeah.
techno music in particular. So we had a really cool panel, like a Zoom panel earlier in the actually last year in 2020 in the summer. Um, where we had several DJs who talked about the role of techno music in fighting the climate crisis. And we went through kind of a deep history of the politics of techno and how techno and house, especially being in Chicago, kind of the birthplace of Chicago house, and being close to Detroit, which is like kind of thought of as like the birthplace of techno, and many of these like many of the communities that kind of popularized this and spearheaded these types of music were like black and brown and queer, which have vested like political interests both you know um, in the climate crisis and not. But I'm thinking specifically like the south side of Chicago with the Chicago House, and how south side of Chicago is really like epicenter of the environmental racism conversation, and how these communities on the south side of Chicago just they dump like the waste from the refineries there. They put freeways right through their neighborhoods. Like the air quality is worse, the asthma incidences are higher. And so I think techno, just like as a political movement, and house as a political movement, really is synthesized well with climate change in general. And then there's also kind of the like literal side of it, which is that what's being used to make music, and like is it environmentally friendly, there are all these things. And like, does techno music like evoke a response in people? And like, I would say it does. And could that be done with climate change in mind? And so we actually we had two Chicago DJs who we had on this panel, and they made mixes, which are both available to listen to on SoundCloud, that are kind of like inspired by the climate crisis and all of that. And I think it's just really cool to be like synthesizing these two things, which are kind of like my two loves in life, which is techno music and
yeah, it's exciting as well. I've really made that connection before between climate justice and those sorts of elements. And then, because I mean, techno and dance music has historically been quite a force for change and radical, and it's because it's so underground and against the mainstream. I'm thinking about the 90s rave scene going against the um, legislation in both Holland and the UK and places like that, where people who like dance music were always sort of ostracized because they were so against what, in quotes, society stood for. So I think it's a really interesting instrument to look at something like that, because resistance to climate change and resistance to societal norms, or pushing the envelope of what's considered acceptable, it's such an interesting overlap. And I just thought that was absolutely fascinating.
Can you say a little bit more about that? What was happening? What you mentioned pushing back against legislation in the 90s in the UK?
Yeah, so I guess in I think 94 it was, the UK government introduced this legislation that essentially stopped any music with repetitive beats being performed,
What?
in specifically because there was a whole free party rave scene which was embraced by young people who were politically liberal and who were resisting, the strictures of conservative society, and those people who had vested interest in that conservative society did not like that. So they tried to shut down all the parties and criminalize it, essentially. Criminal Justice Act, it was called.
My
And they
God.
did the same thing in Holland, because in Holland, gabba and techno and hardcore were very big in the 90s as well. And they did a very similar thing because I guess the establishment recognized the power, the transformational power of young people seizing on a musical movement that represents them.
Wow.
Yeah, and I think there's also like a layer of, I have to say this as a queer person, but I think there's like a layer of queer antagonism too. Like, I'm reminded of like in Chicago, it's not exactly parallel to that, but in like 1977, 78, there was a big demonstration where they burned all of these disco records in Comiskey Park, where the White Sox play. It was kind of like more right wing type people burned all these disco records because they were kind of gay. It was like kind of gay. It was too lefty or whatever. So literally out of those ashes, metaphor intended, rose house music, Chicago house music, as like a form of resistance. Like, no, like you can't take this away from us like this. Um, and a lot of early house tracks are actually just disco tracks, like sped up and layered with like a more kind of throbbing beat to them. But there's a long history of like queerness and just like general like leftist politics, like anti-war queer, like pro anti-racism,
Defiance.
yeah, defiance, yeah, exactly. And so translating that to now, I think a lot of us would agree that the existential crisis of our time is really like climate change, and all of the ways, the intersectional ways that impacts everything. There's so many parallels. Yeah, absolutely. I didn't know that about the UK though. That's super interesting.
Yeah.
Yeah, it's fascinating.
I didn't either. No, yeah, all the ways that the people in power panic and try to shut down anything that they consider vaguely threatening. It's really,
Yeah,
I, I love listening.
The thing that always kind of cuts through that though is art, right? Like art is
Mm,
always able to capture the imagination. Here we are back, the imagination of people
yes.
across the political spectrum. And so that's why I think art is such a useful kind of like tool or medium or however you want to say it to like these things.
Oh, I,
Yeah.
I love this chat so much. This is great. I'm just having a blast listening to you two and chiming in. This is great. Um,
Yeah, I'm having a great time.
Now I
So
want to listen to, now
fascinating.
I want to listen to some techno music though. I'm
I
gonna have
know.
to
Should we
finish
just put it
this.
on?
you should, you should-
The last 20 minutes will just be like a mix. Yeah.
Rave up, yeah. So
yeah.
how did you come to be in the place that you are? I mean, you gave us a little bit of a sort of background of how you went from LA to Chicago, but how did you find yourself in LA in the first place?
Oh yeah, how did I find myself in LA? That's a good question. I guess like, I was born and I spent my childhood in Connecticut, which, is whatever. I
It's
I
a
was
state.
I,
It is one of
it's a
the
state.
states.
It's one of the, it's a state in the United States. Yeah. It's as a little kid, I was always like super nerdy about the weather. I have charts still from like when I was in third grade of like me tracking all of the hurricanes in the Atlantic Ocean.
Ah,
Um, hand drawn. I've got like spreadsheets and hand drawn things of like when we had heat waves and when we had cold snaps. And so I was always really interested in this. And so when I was looking for what I wanted to do when I grew up, so to speak, I was like, I definitely want to do something with the weather, but I went to the University of Connecticut for my undergrad, and they didn't have like a degree in meteorology. So, which, is fine. I was like, it's in state, the tuition's low. I was paying for it myself. And so I was like, uh, we'll figure it out. And while I was there, I took a class. They had a class on meteorology and they had a department like natural resources and engineering or something like that. Natural resources management and engineering was the department. And one of the grad students who was working in that department was teaching a class on meteorology. And so I took it and I was like, this is amazing. I still have the book from it in my office, like from 2003, I think, or something. Um, and uh, and so I went up to her after the class and I was like, do you need anyone like to help you with your research? And she said, yeah. And so I did some undergraduate research. Basically, she was looking at like, I'm gonna, I don't know if I should say it because I probably can't remember the specific details of it, but her name was April Hiscox and she still has like, she's still doing this research. I think she's like a professor in Louisiana or something like that. I'm sure I got all of that wrong. But anyway, basically, she was looking at gravity waves over a forest canopy. And she had constructed a large tower that went above the canopy. And so my job as an undergraduate researcher was to climb up the tower and like make sure that the anemometer and the temperature thermocouples and everything were operating correctly and that the data were downloading correctly. And then she did a lot like give me an opportunity to kind of look at the data and make some graphs of the data. Stuff cooperate. My senior year, I did like a thesis. I was in like the honors program at University of Connecticut, and I did my thesis on like winter snowfall in New England. And I was like, I think I want to do this. Like, I think I want to study this. I feel like this is a big deal. I feel like climate change is a big deal. And so I talked to a bunch of people at the school, and they were like, you should look at graduate school programs. And I looked around and I found a program at University of California, Irvine, UCI, and it looked really cool. And I emailed my soon to be advisor, and I was like, I think I want to do this. And he said you should apply. And I applied to one graduate school, and I got into that one, and I went there, and that's what happened. I like started doing work at UCI. I had no idea what I was doing. I was like 22 years old, and I was like, I want to do something about this. It seems like a big problem.
Yeah.
And it was
in.
honestly really cool. The program at UCI is amazing. It's like one of the first programs that brought together the different disciplines of earth science, let's say. So it was like there was hydrologists and there were oceanographers and atmospheric scientists and climate modelers and paleoclimatologists and everything really, like atmospheric chemists. So it was super cool, and I got to take all these classes, and I was like, this is definitely what I want to do.
So you've always been somewhat interdisciplinary.
Yeah, I was gonna
That
say that.
sounds like.
Yeah, that's right.
Yeah, I guess so. Yeah, I mean that was a big draw for the program for me, was that it was interdisciplinary, that it was because I didn't know, I was like, I don't know, I want to like save the world, I'm a millennial.
Yeah.
So
Ideally,
like,
yeah.
Noble cause.
That's really cool. That's really exciting.
Yeah. It was
well,
cool.
and so Ella, I know you've got to go, so I want to make sure I give you an opportunity. Like anything else you want to ask? I mean, we've got another like 20 minutes, so we're not like urgently running out of time, but I want to make sure that you feel comfy and have had a chance to ask everything you want to ask.
I've ticked my techno box. Ticked my cloud box.
I'm gonna have to send you some. I'm gonna have to send you some good techno SoundCloud mixes.
Please do. Yeah. I would love to hear those mixes you were talking about.
Oh yeah, for sure. I'll send you the ones from our panel as well. Yeah, one of the DJs, Ariel Zatina. I don't know. Maybe you've heard of her. She's from Chicago. She's very much like blowing up, I guess you could say. I think she's like just really phenomenal and has a lot to say about both techno and like the world, and is also a trans woman, which I love.
So. Yeah. If you like, if we remember in the right time, I can put that on the tweet and stuff. Like when I promote the episode and things, we can put those SoundCloud. Like if there's playlists and things, we could tack those onto there. That would be a good
Yeah, that would be cool.
addition, I think. Um, so one of the things that I did want to ask a little bit about, and I want to put the ball in your court and say we can talk as much or as little about this part as you like. But I was wondering if there was more that we could do in the science community to kind of support people with different gender expressions. Like how are we doing right now? Are there things we could be doing better? Um, that's one side of the perspective, right? And then the other perspective, I guess, would be if you had advice or things to say to people who maybe were going through some gender exploration, trying to figure out themselves in relation to this big professional field that we're in, whether they're students or more advanced or whatever. So I'll kind of give you those two possible angles, but the ball's totally in your court. As much or as little as you feel like. I'm very happy with to let you take the lead there.
For sure, yeah. I do have a lot to say on that. I
Mm.
think, you know, I think something that's really interesting, maybe interesting is not the right word, but something that I hear a lot is that, you know, gender, sexuality, politics, whatever, you shouldn't bring that into your work.
Mm.
You shouldn't bring that into your research. And I just like vehemently disagree. I think that's um, something that like a white man would say, a straight white man would say. And
I
the
know
reason is
the
that
internet.
default apolitical.
Or our connection. Oh,
What's
sorry,
that?
our connection was bad for a second. Sorry. I think we're back now.
Oh,
Okay,
you
go
still
ahead.
have me? Am I still here?
Yeah,
Okay.
you're still here. You're still here.
Um, yeah, so I guess I'll just say that again. I think like something that I hear a lot is that you shouldn't bring your queerness or your gender or your politics or your race or whatever into your
Mhm.
work. And I just disagree so strongly with that because I think the apolitical kind of like what people accept as being like apolitical default is like this like cis straight white man, right? But that actually is an identity. That's not an identity, but it's
Mm,
become like the non-identity is if you're a white man. So then if you have another identity, you're told like you're being too political if you think about it.
mm,
But it's like why? Like my identity informs my work. It informs how I view the world. It informs the questions I ask, the data I look at, the way in which I approach this. And so I think like my the big holistic message that I would love to get across is that we have to stop pretending. We have to stop saying that science is apolitical, unbiased, because actually it's or divorced from identity, because it's not. It is actually like
mm.
it's the identity of the scientist is like a cis straight white man, and and that has informed the way that science has been conducted for millennia. I'm always drawn to a tweet that I saw by Neil deGrasse Tyson, who I know maybe has been like sort
There's,
of canceled. It's
there's some
hard. I don't know
problems.
what.
There's some problems. Yeah.
Yeah, I don't know where we are with that, but I still think the tweet was good. And it said that we probably could have solved climate change if we had allowed women to participate in the same way that men participate in the scientific endeavor for the last several hundred years. And while I don't know that that's like necessarily true, it really makes me think that like the way we've approached science, the way we've approached the production of scientific knowledge and the dissemination of scientific knowledge has always been driven by one identity, which is that of the like straight white man. And I'm definitely sounding like a social justice warrior here, which is not my intention. My intention is really just that all identities are really important, and actually you can achieve so much more knowledge. You can produce so much more knowledge. You can achieve so much more dissemination of knowledge when you include other people with other identities in that
It's
process.
like
And
we were saying with the art thing, like if you bring a different perspective, you're going to ask different questions. You're going to have a different set of eyes on the problem. And if you were an artist, you'd probably be embracing that identity difference
mhm.
and putting that into your work. And that would be very much acceptable and encouraged. Whereas
Yeah.
in science, it's this, we're very objective. But no, of course you can't be. Everything is subjective. The entire way you do everything is subjective. And you
Yeah.
can't remove your humanity from anything you do.
That's a great
Exactly.
So
point.
yeah.
I always say like we like to think that science is the pursuit of truth, and while I do kind of agree with that overriding message, um, it's also driven by humans. It's conducted by human beings, and there's always going to be, the human like identity and other politics and whatever as part of that. And so I think that um, you know, from a really broad sense, I would just love for the kind of image of a scientist, let's say, to stop being like a white dude.
Mm,
In a
Not
lab
not
coat.
in a lab coat, an old straight,
mm,
cis white man. It's very much like I teach in my class about I have an environmental disasters class, and I teach about nuclear power, nuclear energy, and the atomic weapons. The invention of and deployment of. And one story I always tell is that the reaction that produces, the energy, excuse me, nuclear fission reaction, um, was kind of discovered by these two guys that were just like bumbling around in a chemistry lab. But it was explained by a woman who was actually in exile from Germany because she was Jewish. This was in the 30s, and she
mm,
gets almost no credit for this. But she really wrote the physics paper. Her nephew,
mm.
probably because he was a man. Um, but oftentimes these other people get credit for it. Hang on, I'm sorry, my
Oh,
dog is like barking because he's
oh,
mad that he's not in the room, so I'm just gonna let him in. Come on, pup.
oh, yeah, no worries. Well, on that note, I don't know if it's picking up on the recording. My son's having a very loud Minecraft game downstairs, so it's possible that people might be hearing just the edges of that. So don't worry, there's plenty of
I
noise
know it's
around.
that, but you can say hi to my dog. There he is.
Oh, hello.
Is that a knitted jumper?
Oh my
It is,
gosh.
yeah.
Please tell me you knitted that.
No, I didn't. But my partner works at a pet supply shop, and so that's where we got it from. He always has the best and finest dog
Best
attire.
regalia, yeah.
That's amazing. That's amazing.
Um, yeah, but I mean, to elaborate more on your question, I think there
Hmm.
are some concrete ways that like the scientific kind of industry or whatever the field of science can support trans people and that sort of thing, which is like um, just like being understanding and like being open minded and being ready to listen when people say things instead of being
Hmm.
stuck in your ways. And yeah, this is definitely tied to the art thing.
Yeah.
Like they're one and the same in that like these different perspectives are like so important. I
Yeah.
also will say that for anyone who is like questioning their gender or queer or thinking about these things, like I'm very public about my transition. I'm very public about my identity, and I'm easy to find on Twitter and all of that. And I welcome messages. I welcome messages from people. I talk to a lot of people every week about this. So
Yeah. Yeah. Actually, yeah, if you don't mind me saying this, I hope you don't, but you probably won't. But you being so open about your transition, because I've been following you for a long time, since that around the time when we hung out at EGU and then a little bit after that we were talking about at the beginning of the chat. So seeing you be so open about that, not that this was the point, but this is something I got out of it. So like that opened my heart. Seriously, like that was something that, this is somebody I know. Here's the specific thing they're going through, and like you were reporting your internal states, and you were reporting the things you were going through, and like just opened my mind and my heart up. And I'm really thankful for that. I really appreciate that. And
thank you. That's really nice. I
yeah,
appreciate that. I'm glad that it was like, helpful. I think that was my point. It's not always been easy necessarily, but I think um, it's nice to hear that. So thank you. That's really
mm,
sweet. I really appreciate that. I think, I'm a white person, and I have a job, and so I think I have a lot of agency to be really open about these things. And so I think I like to do that for people who can't be as open, for people who can't or don't want to or don't have the agency or the access to be as open, because I do think like um, for people who can be open and do the things that I've done, it is really helpful for cis people, and for non-trans people. And so it's nice to hear that, because I think like sometimes I'm like, is this getting through? And then every now and then like I'll get a message like that from someone, and I'll be like, okay, it is important what I'm doing, even though it's not
Yeah.
always easy.
It's about being able to imagine yourself in that role, isn't it? It's saying, hey, I can see somebody who looks like me doing that thing, and I never thought that I could do that, because science is so typically heteronormative and white and male. And changing that perception is so vital to encourage people of color and people of different gender identities and different sexualities and all sorts of different people, rather than just having everyone fit that same mold. And then you're going to get that diversity of approaches in science and self-climate crisis. There we go.
Exactly.
That's the solution.
And I like to think
Done. We fixed it.
Done. Yeah, I think you're absolutely right. I like to think of myself as sort of part of this zeitgeist too. I think the more people that are in this moment doing these things, the better it's going to get. And I mean, one example that I have is I was invited back to UCI to give a talk in the fall. It was virtual, but I suggested that we set up like a queer happy hour Zoom with the folks in the department, and there was like 20 people on that Zoom. And then when I remember when I was in grad school, I think I was the only queer person that I knew, and that was only like 15 years ago, you know.
Yeah.
So it's like amazing how a decade has really changed the way that science and queerness and gender too, like not just gender identity, not just trans people, but just like I think women and non-binary people in general, and the way they participate in the science and the way they're regarded in the scientific process has come so far. Has so far to go, but has come so far. And my heart was like really warmed when I like logged into that Zoom and I saw like 20 people in this like queer happy hour, virtual queer happy hour, like in a pandemic. Super cool.
Yeah, it's amazing. It's great that things have developed. I often think it's worth reflecting a little bit on how far we've come, because it can be easy to lose hope. And then you think, hey, where were we 15 years ago, though? It's definitely better.
Yeah. No, I mean, I remember like the 2004 election so viscerally when like, the Republican Party basically ran on banning gay marriage. I mean, that was like part of their platform. That was like a huge tenet, and they were able to pass all these like amendments in all these different states in the United States that banned gay marriage. That was in 2004. Now it's like, so different. And so I think it is important to like reflect on that. I think you're right. I think oftentimes the left, which I consider myself a part of, thinks about ways that we can make the world better, but we never think about ways that we've already kind of made the world a little bit better. And I think it's really important to take stock of that sometimes.
Yeah, and it helps you imagining the future, as we have spoken about already.
Oh, look at that. You tied it all back together in a nice little bow. Ellie, you're good at this. Did you know that?
Oh, thank you.
Yeah.
No, I think it's been such a fascinating conversation. I've really, really loved speaking with you and hearing about all the incredible projects you're involved in. So really want to thank you. That's blown my mind.
Thank you so much for letting me come on, and I'm really glad that I agreed to this podcast. I know I was like posting how much I hate podcasts on Twitter, and Dan, you were like, "Oh no," and I was like, "No, it's fine. It's just like a spicy hot Twitter take, It's okay."
Yeah. So for just for context, I think I mentioned this on Twitter too, that like I was up front with like, for some reason I wasn't really doing that great that week. And like, yeah, that's right. And I don't, so because normally I think I'd be able to see something like that and recognize that like, oh, okay, yeah, it's just a thing on Twitter. It's fine, relax. But for whatever reason in that moment, I was like, but they're so important and I like them so much. And so just had that sensitive reaction to it.
I think I was like maybe kind of responding to, and this might be an American thing because y'all are in the UK, maybe you're not as in tune with this, but there's been like kind of an explosion of like leftist men who have podcasts, and I find like so many of them to be like both redundant and like annoying. I don't know like how to necessarily describe it well. And like in particular, there was this moment at the beginning of the year, this year, where like some leftist podcasters were kind of going after Alexandria Ocasio-Cortez and others for like not. It was this very complicated thing which you can research
Oh,
and look up easily. You can Google for it. But I was just like having a moment where I was like annoyed, and I was like, let me just make a spicy take. But then I was like, oh shoot, I agreed to do this podcast, so I guess I better like clarify that
Take it back.
not directed at all podcasts. It just definitely was like this kind of spicy take, which I
yeah,
am known for. So,
indeed. Yeah. Well, it
Well, may that continue.
sounds like a bunch of people were trying to be Mark Maron and probably just not cutting it, I would imagine. So yeah, sounds what that kind of sounds like effectively. Um, gosh, thank you so much. This has been so good. I've really appreciated it. And so Ella, I know you've got an appointment like in 3 minutes, right? So I should probably
Sad times, yeah.
yeah. Can
I could stay on all night.
I know, right? Mika, can you stay on just a little bit beyond, a little bit past 6:30, if that's okay?
sure.
Cool.
Yeah.
Thank you. I'd appreciate that. So anything else?
Cool.
I know I've kind of said that, but are we all happy with the episode? Feeling good? Anything else we want to talk about?
No, it feels great. Thank you so much for
Yeah,
like
same.
inviting me. It's such a pleasure to meet you, and I hope that when this like pandemic is over, maybe we can like have a drink at EGU or something. If you ever
Yeah.
come to EGU or what, we love that.
Sounds amazing.
I
Yeah.
do.
Be
I
good
would
to
love
stay in
that.
touch.
Yeah, absolutely stay in touch, please.
Yes.
Please. On Twitter, my Twitter is trans icon Mika. I'm
Mm-hmm.
sure maybe you've already found me.
Probably, yeah, I'm fairly certain I have, but I'll double check. Anyway, I better shoot, but
Yeah.
it's been a pleasure, and
Yeah.
see you soon
Yeah.
See
Thank you, Ella.
on the internet. Ciao.
Don't worry. We're gonna stop the podcast. We're not gonna do more podcasts without you. Don't
Yeah,
worry.
you
We're not
better.
gonna. Yeah, we're gonna. Like yeah.
See
Okay.
ya.
Now she's gone. Now.